Hi, and welcome to Linear Functions and Slope Notes for NTI. So, starting this off with the review of slope. Slope, its variable is normally m, and you recognize it as rise over run, delta y over delta x maybe, or that delta means change in y over change in x. And mathematically, change is represented as subtraction. So like y2 minus y1 over x2 minus x1. So you've seen some form of slope before. And I also wanted to point out that if we take a triangle that's graphed, this side of it is going to be the far right x value minus the far left x value. So that's why the order of 2 and 1 are swapped. Same thing for this side with y. So you've got y2 minus y1. So geometrically, you're dealing with the hypotenuse of a triangle if you define the change in y and the change in x. So y is slope in pre-cal because you've dealt with it in every other math class. So for slope, this is the fundamental way we view data in math, right? We look at graphs, we check the slope. What's happening with the slope? Are we observing a speed? Are we observing a trend in something? Positive slope is important for measuring some things. It's got to be useful somewhere, right? So in calculus, we actually use it to measure rates. So use slope to measure rates. You might be wondering, rates of what? Well, we have speed as a rate, we have population growth as a rate, we have more complicated things like the rate of customers entering a restaurant, for example. There are plenty of examples that can be observed, but for now, that's what we'll sit with. So the equation of a line that we're going to discuss, we've got a couple, right? And you should probably have this in mind as well. Y equals mx plus b. But the one that I prefer for this class is y2 minus y1 equals m x2 minus x1. And this is called the point slope form of a line, point slope equation. This, of course, is y-intercept. The reason why I don't like y-intercept is because it's not as explicit. It uses b as a combination of these x and y constants. So it's a little bit easier to start off with point slope and then work your way towards a more understandable equation and more easily graphed equation as y equals mx plus b. I wanted to start off with looking at a graph and graphing from, taking an equation from a graph. And to do that, we have to pick points that are on our graph. This one's not so bad. And we need to use the equation. M is the change in y over the change in x, or rise over run, or y2 minus y1 over x2 minus x1. So we need to pick the points we're going to use. And here the scale might be throwing you off, so make sure you pay careful attention. The 2 points we're going to use that are on this line are -2, 0, and 0, 4. So we're just going to represent those in our slope equation. Of course, this isn't a very rigorous example for what you see, because you can see the slope as well, but it'll work the same way. So we have a double negative for that first point, meaning our slope is 2, it's positive. And if you remember, positive slope goes up and to the right, like this one does, and negative slope would go down and to the right. Okay, so we already have the slope, but we need the equation of this line. So if we were to take point slope, and we would be like, la la la, put all this stuff into point slope, because I'm fulfilling what all these variables are, that's not very helpful, because we end up with just a statement on what slope is. We get one side equals the other. That's not great. So what we actually need to do is remove one of the points. So I'm choosing to remove this point. So we represent our line. That should be an X. We represent our line with variables, as it should be. And we'll end up with a nice y equals mx plus b format as well. And so that tracks with our graph there on the right, and there you have it. Now this is the first of 5 different ways that you might see slope, and what I'm going to do is I'm going to work through these problems. I'm going to stop along the way if something comes up like perpendicular slope and explain what that is. But for the most part, I'm just going to show you my solutions, and you can copy down the rest of these notes. So there's a couple things I want to point out. Notice that I've used 10, -1 as the point that I'm taking. So I'm taking from that coordinate pair, and I'm not using the other one. Also, I am writing this equation as y equals mx plus b. This one's not so bad, but I'm also clearly labeling some things as well. So like m, that needed to be labeled, so I can just quickly transfer this in my brain, like, oh yeah, m goes there, and I've just made it easy for myself to track my work. Also, I'm working down. When you do this, I really encourage you to start working down. It's going to be much easier when the problems start to get too large and too complicated for you to start working across. Across the page, it gets pretty confusing to look at. Okay, so something that is perpendicular. A slope is equal to a over b, and if we were looking at the perpendicular slope to that a over b, then I'm going to use a perpendicular symbol. The perpendicular slope is going to be -b over a, so that these two lines would cross at 90-degree angles. And parallel slope would obviously be the same slope, a over b. So we got parallel m equals a over b. And now that we have that information, we can clearly say that the slope for this line ought to be -5 over 3. So here for this one, we have to rewrite this equation so that we can see what the slope is, which isn't too bad. So our last example has something that I'm labeling with other context. So this other context could be just a clue of where it is on the graph. So here, this is this line passes through the x-axis at x equals -5. So you have to know what that means, right? So what is the the point that this line goes through if it passes through the x-axis at x equals -5? Well, on the x-axis, just we'll use this one, y is 0, right? So we know that the point that this is talking about, when it says x equals -5 and it passes through the x-axis, and we know it passes through the point -5, 0. So we actually have everything we need. So we're actually not going to graph this one. And that's it. So make sure you're practicing and you are ready for your homework check. Thanks.